All right, welcome back everyone to the deep dive. Today we're diving headfirst into something, well, kind of crucial, especially for those of you gearing up for those senior software engineer interviews. You know the ones? And we're talking all about how microservices talk to each other. Because guess what? When system design pops up, and it will cost, you gotta know these patterns inside and out.
Absolutely. It's funny. I was just talking to a friend of mine about this the other day. He's a hiring manager at, well, I can't name names, but a pretty big tech company. And he was saying how so many candidates sort of stumble when it comes to actually explaining how they'd handle communication between services in a distributed system.
Yeah, totally. And it's like you can have the coolest microservices in the world, but if they can't actually communicate effectively, the whole system falls apart, right?
Right, exactly. It's like having a team of experts who all speak different languages. They might be brilliant individually, but they can't get anything done if they can't understand each other.
So today we're tackling two major ways these services can exchange information. It's almost like two opposite ends of a spectrum when it comes to how closely connected they are.
Yeah, think of it like this. On one end, you've got what we call communication through common data. It's kind of like leaving a note for someone, right? One service puts the information out there, and another service picks it up later when they need it. Totally asynchronous, no need for everyone to be online at the same time.
Gotcha, like an inbox or a message queue or something.
Exactly. And then on the other end of the spectrum, we've got this more intimate approach. Picture this. Multiple services all working directly on the same piece of data. Kind of like trying to co-author a document in real time with everyone making edits at once.
Oh yeah, can definitely see how that could get messy fast.
Yeah, lots of potential for conflict and confusion.
Wow.
So understanding the trade-offs between these approaches is key, especially for those interview scenarios you were talking about.
Okay, so let's unpack this communication through common data idea first. A really common example you'll see in the wild is file-based integration. Picture this. You've got a new product importer, microservice. Its job, it ingests all the juicy details about, well, new products, obviously. And then what does it do? It spits out a new product file. Simple as that.
Boom, new products, all neatly packaged in a file. And here's where things get interesting. Let's say you've also got a catalog microservice, the one that showcases all your products to the users, and an inventory microservice, which, you guessed it, keeps track of how much stuff you have in stock. Both of these guys, the catalog and the inventory, can grab that new product file created by the importer.
Ah, so the catalog service updates its listings, and the inventory service adjusts its stock counts, all based on that one file.
Precisely. And what's really cool here is the level of independence it gives you. We call this loose coupling. The new product importer just drops the file and says, "Here you go, world." It doesn't have to worry about when or how the catalog and inventory services are going to process it. They do their thing on their own time.
Yeah, and I guess another nice bonus is that you've got this permanent record of the new product data right there in the file.
Exactly, like a little data trail. Now, from a technical perspective, this communication is all asynchronous. The new product importer doesn't hang around waiting for the catalog and inventory services to wake up and grab the file. It just moves on to the next thing.
Right, so how does this usually work in practice? I mean, are we talking fancy message queues or...
Well, sometimes, but often it's much simpler than that. The importer might just save the file to a shared folder, like a network drive or something. And then the catalog and inventory services will just periodically check that folder, we call this polling, to see if any new files have shown up.
Ah, so like checking your email every so often for new messages.
Yeah, pretty much. Now, here's a bit of a brain teaser for you. Even if a service internally uses some super fast asynchronous way to read the file, maybe they load it without blocking other operations, the overall interaction between the services is still asynchronous. It's all about that timing independence.
Makes sense. So from an interview standpoint, what are the key takeaways here? When would you choose this file-based approach, and when might it not be the best fit?
Good question. So on the plus side, it's often incredibly straightforward to set up. You're usually working with familiar technology like files and folders. This can be a lifesaver when you need to integrate with older systems that might not be up to speed with the latest and greatest communication methods.
Yeah, like if you're dealing with a legacy system that still loves its CSV files.
Exactly. Also, if you've got massive amounts of data to transfer, files can be pretty efficient. It's like sending a big package all at once instead of sending tiny little bits of information back and forth.
Right, kind of like bulk shipping versus sending individual letters.
Now, the potential downsides, well, if you absolutely need real-time, super fast updates, This polling approach might not cut it. That periodic check introduces a bit of a delay, right?
So for situations where every millisecond counts, maybe not the ideal
Yeah,
solution.
exactly. And there's another subtle thing to keep in mind. If the structure of that shared file changes, like you add new columns or something, suddenly all of those services that rely on it need to be updated as well. So while the services themselves aren't directly dependent on each other, they're still kind of connected by that shared data format.
Ah, so a change in one place can ripple out and affect others. Makes sense.
It's worth mentioning that one way to improve the latency could be to combine this file-based approach with notifications. For instance, the importer could drop the file and then send a little message to the other services saying, hey, new file's here, come and get it.
Makes sense. Okay, so that's communication through common data in a nutshell. Now let's flip the script and talk about that more intertwined approach, that database-centric integration idea. What's the catch there?
So here's a classic example to illustrate this. Let's say you're building an e-commerce system, and you've got an order processor microservice handling, well, orders and payments, and a warehouse microservice managing the picking and shipping of those orders. Instead of passing files back and forth, both of these services are going to work directly with the same order table in a database.
Okay, so picture this order table. We've got columns like an ID for each order, customer details, maybe some order items, and importantly, a status column. This status column tells you where each order is in the whole process.
Right, so the order processor might set the status to placed when someone submits an order, then to paid once the payment goes through, and eventually to completed when everything is done and dusted.
And meanwhile, the warehouse service is also peeking at that same status column. When they start picking the items for an order, they might change the status to picking and then finally to shipped when the package is out the door. Both services are reading and writing to the same piece of data, sometimes at the same time.
And that's where the real challenge lies, this tight coupling. Think about it. If both services try to update that status column at the exact same moment, things can get really messy. You could end up with inconsistencies, data corruption, all sorts of headaches.
Yeah, like a real-time editing war on a shared document.
And this direct sharing can make things tricky when you need to update or scale your system. Let's say you need to make a change to that order table. Now you've got to carefully coordinate the deployment of both the order processor and the warehouse microservices to avoid breaking things. It can really slow you down.
So it's like you're constantly walking on eggshells, making sure everyone stays in sync.
It's not all bad, though, right? This approach does have a certain appeal. It can feel simpler at first glance to have all your order data in one central location.
Yeah, I can see how that might be tempting. But you mentioned some drawbacks, right?
Exactly. A big one is that it creates a very different flow of information compared to that common data pattern we discussed earlier. With files or data lakes, it's usually a one-way street. One service publishes the data and others read it. But with this shared database model, everyone's reading and writing all the time, which creates this tangle of dependencies.
So in an interview setting, it sounds like it's crucial to demonstrate that you understand the implications of tight versus loose coupling.
Absolutely. And you should be ready to explain the pros and cons of each approach, not just say one is better than the other.
Right, because there's no silver bullet, right? It all depends on the specific needs of the system you're building.
And interviewers want to see that you can think critically about these choices. For example, maybe file-based integration is the most practical way to handle things when you're dealing with a clunky old legacy system that just won't play nice with modern APIs.
Yeah, sometimes you got to work with what you've got.
On the other hand, while a shared database might seem like the most direct way to handle transactional data, it's critical to recognize the risks associated with that tight coupling.
So as you're prepping for those interviews, it's all about being able to analyze these different communication styles and explain how they impact the overall system.
Exactly. Because ultimately, designing a robust microservice architecture is all about finding the right balance between data sharing and service independence. And these two patterns we've discussed really highlight that tension.
All right, so let's recap what we've covered in this deep dive today. We started by exploring communication through common data, using that file-based integration example. We highlighted how its asynchronous nature and loose coupling make it a great fit for certain scenarios. Then we contrasted this with database-centric integration, also known as common coupling, which, while seemingly simple, can introduce a whole new level of complexity with its tight dependencies.
And remember, understanding these nuances isn't just about acing interviews. It's about building real-world systems that can scale and evolve without, falling apart at the seams.
Couldn't have said it better myself. And to leave you with something to ponder, let me throw this out there. In a distributed system, it's practically impossible to keep data perfectly synchronized across all your services all the time. This is what we call eventual consistency. So how might your choice of communication pattern, whether it's loosely coupled or tightly coupled, affect how you tackle this challenge of data synchronization and maintaining data integrity? It's a fascinating area to explore as you delve deeper into distributed systems. Until next time, happy coding.